so we're going to talk about inverse functions. We're going to talk about them briefly, graphically, and then we're going to do them, and then I'm going to show you the new notation that we really need to be aware of. So first of all, if we have the function y equals 3x plus 2, by now you should be like, oh, Mr. Lynch, it's a linear equation. The y-intercept is 2. It has a slope of 3. It basically looks like that, right? So we could say that this is the point 2. And then the point 1, 5 is on the graph, right? So that is the equation of this line. The inverse of this function is the function that undoes this, right? So if I plug in 1 into this, I get 5 out. If I wanted a function where if I plug 5 in, I get 1 out, that would be the inverse, right? So right now, we know that f of 1 equals 5. The inverse function, if we knew what it was, and I'm going to use some funky notation here in just a moment, that little -1 means inverse of 5 would be 1, right? So we just need to do the thing that undoes it. So graphically, an inverse is a function that is symmetric about that point. So we can look at it and, I'm sorry, not that point. Symmetric about the line y equals x, right? So if we were to graph this, well, if it's symmetric about the line y equals x, then because it intersects there, it has to be symmetric on that point. This 2 would get mapped over here to a 2 over here, and maybe this isn't going to look to scale. And this 5, 1 would have to be over here at the point 1, 5 would have to be mapped over here to the point 5, 1. So our symmetric graph, or our inverse graph, would actually look like that. So it looks like our graph has a negative y-intercept. It also has a slope that is less than this one, right? So now we need to, if we can see it graphically, what we need to be able to do is calculate it. And calculating it is actually pretty easy. What we need to do is solve this equation for x. We are going to turn this equation around and solve it for x. So we need to get x by itself. If we need to get x by itself, the first thing we have to do is deal with that plus 2. So we're going to subtract 2 from both sides. And then we'll say y minus 2 equals 3 times x. Now it's 3 times x. So to undo that, we divide both sides by 3. And then we end up with y minus 2 over 3 is x. So we're mostly there. We can rewrite this if we want, just so we can see it like we would see most of our linear equations. And because they're both being divided by 3, I can break it apart because they both have the same denominator. And I can say that this is really 1/3 y minus 2/3 is x. And if we look at this real quick to compare it to our red function and green function, well, I said in the red function we were going to have a y-intercept that's less than 0, which it does, -2/3, and we were going to have something that is not as steep, and 1/3 is not as steep as 3. You'll also notice that the slope will always be the reciprocal, right, when we start talking about inverses. So this is my inverse function. And the way we write it, right, the last step is we just have to swap out the x's and the y's, right? Once we swap the x's and the y's out, then we're all set. So the function 1/3 x minus 2/3 is y is the inverse of that function. Okay, they are inverses of each other now. Okay, so let's do that again, and I'm going to use function notation this time. A little less background information. So I want to find the inverse of 5x plus 2. All right, let's make this a little different. Negative 5x plus 2. Okay, I want to find the inverse of this function. So the way that we would write that is with that little negative 1. This exponent of negative 1 means inverse. It undoes the other function. Okay, so my job is to now calculate it. So I'm going to leave this green up here as a space for me to put my answer when I get my answer. When I do the work down here, I'm going to say that y is negative 5x plus 2. And just like before, I said we need to solve this function for x. So I need to move the 2, so I'm going to subtract 2 from both sides. Y minus 2 is negative 5x. Now I'm going to divide everything by negative 5. Y minus 2 over negative 5, almost looks like an x, is x. So I'm basically done. I'm just going to clean this up a little bit and say that this is negative 1/5. Oh, that's a terrible 5. Negative 1/5 y plus 2/5. Negative 1/5 y plus 2/5. And when I go to plug this back up here to say, hey, I've got my answer, all I have to do is just swap out that y. And I'm going to say that my answer is negative 1/5 x plus 2/5. Okay? And yeah, this should make sense because we have a slope that is less steep, and it's 1/5. It's the reciprocal of that slope, and that's good. This part might not make a lot of sense, but we're going to just test it with a number. What if I found f of 3? Well, f of 3 is 3 times negative 5 is negative 15 plus 2 is negative 13. Okay? And if I wanted to do the inverse, and I plug in negative 13, I better get an answer of 3. So where can I do that? I guess I'm going to just squeeze it in here. F of inverse of negative 13 is negative 1/5 times negative 13 plus 2/5. Can you see that? Yeah, you can. If I multiply this by this, I don't want to do it, but a negative times a negative is a positive, so I end up with 13/5 plus 2/5. And good news, I've got the same denominator, so I can just add them. So that becomes 15/5. And I think we all know that 15 divided by 5 is 3, which is that answer right there. So we know that we have the right answer. The inverse is right there. So all you got to do is solve for the other variable and plug it, and then switch the variables and plug it in. Okay? Looks complicated. It's not too bad. Good luck. Please send me an email if you have questions. Thanks. Bye.